A2 Somigliana formula. Now, Somigliana, it's kind of like the word lasagna where the G is silent. Somigliana, just imagine the G not even being there. Somigliana. Somigliana's formula for normal gravity, they write it out for you here. Symbol gamma is used for theoretical gravity. Now, the gravity you find in your introductory physics course, G, it's really the same thing. It's just that G is the measured value, while gamma stands for theoretical calculation that we're going to be doing. So 9.8 meters per second squared. So the formula is, which is the goal of our course, we have here the semi-major axis. So we're looking at, think of the Earth, where you have your semi-major axis and semi-minor axis. And then you're going to multiply that by the gravity at the equator. That would be here. And then hit it with cosine squared phi. And phi is the angle. If you're standing, say, here, you put a normal in there. And the angle made with the horizontal is phi. It's the latitude. That's what we would consider the latitude. And here we would add to this B, the semi-minor axis, times the gravity at the pole, the poles, just like this is the equator. Equator goes all the way around, of course. And that's sine squared phi. And then we divide all this by the square root of a squared cosine squared phi plus b squared sine squared phi. Cool formula. The A goes with the gravity at the equator, and some folks like to refer to that gravity as gamma sub A. And over here, gamma sub B. So you could write it that way if you like. Might be easier to remember. So you have cosine first, and then you have the B, the gamma B, and then you have the sine squared second. And then we're dividing by the square root of a squared cosine squared phi plus b squared sine squared phi. This is our course to derive this. That's it. It's like a simple goal to derive the Somigliana formula. It's a cool formula. So that's our section 2.